Maybe. All right, I believe we're recording. All right, so this is the homework answers for 6.2. So you can grade yours and see how you did. So this is off this worksheet, 6.2. We did the evens. Number 2 and number 4, we did our notes yesterday. Hopefully you noticed that, but just in case you didn't, the zeros for number 2 was 0 and 8, which had a multiplicity of 2. It occurred twice. Number 4 we did together. Its zeros were 0, which had a multiplicity of 2, and was it 4? It's a multiplicity of 2. And then number 6 you had to do on your own, and it looks like you have a 0 of 3 with a multiplicity of 2. And what's your other 0? Anybody else get the other one? There's one more. Yes. The other one, you would take, so you have this one right here where you, the 3 comes from that right there, x minus 3 squared. If you said x minus 3 equals 0, you get 3. Here's your other factor, 2x plus 5. It's okay that there's a 2 on the x. Still set it equals 0. If you go 2x plus 5 equals 0, you get 2x equals negative 5. X equals negative 5 halves, or negative 2 1/2, or whatever you want to call it. So the other 0 was a negative 2.5, or negative 2 1/2. Did y'all get that? Okay. Number 8, write this polynomial in standard form. There's a lot there. So it would be 2x plus 1 times x minus 3 times, I want to rearrange this last one. I want to write it as negative x plus 5, just for my brain. And what you multiply first is up to you. What did you guys multiply first? Somebody in the crowd tell me, which 2 did you multiply together first? And first one. So if we do these 2 to start, we should have 2x squared. We'd have a negative 6x and a positive 1x, so that'd be a negative 5x minus 3. And you still have this negative x plus 5. And then if you take negative x to everything, you would get a negative 2x to the third plus 5x squared plus 3x. That's the negative x times everything. And if you take the 5 times everything, you get plus 10x squared minus 25x minus 15. This is still all y equals. So this answer, if you were to answer this one completely, what do you have? Stephen? What do you have? What's the final answer down here going to be? What's our cubic term? What does somebody have as their cubic term? Negative 2x to the third. That one doesn't change. No other cubic term. How many x squareds do we have? Well, I mean, what would the coefficient be? What's your coefficient for your x squareds? 15. What about for our linear term, our x to the first power? Negative 22x, y'all have that? And our constant is minus 15. So there's your answer to number 8. Number 10, write a polynomial in standard form for the given zeros. Oh, good point, thank you. Not number 10. Start down there at 14. 14 says write each expression as a polynomial in standard form. So 14 is x times x minus 2 squared. I would do the x minus 2 squared to start. Oh my goodness, thank you, x minus 1 squared to start. Yep, that's why you gotta be paying attention. You never know when Mr. Bush will be looking cross-eyed up here. So if you just do the x minus 1 squared to start, that's saying x minus 1 times x minus 1, which would be x squared minus 2x plus 1. Right? Right, maybe? Yes. And then take the x and multiply it through. You would have x to the third minus 2x squared plus x. So that would be those multiplied into polynomial form. Woo, that's, then, look at here. 16 might be the longest one on the page because you have an x plus 4 times a 2x minus 5 times an x plus 5 times an x plus 5. Because it's x plus 5 squared. That's a lot, isn't it? It is a lot. Did you do it? Good. What I'm going to do is I'm actually going to multiply these first two and these second two. We'll have two different trinomials then. So this first two, we give you 2x squared. You'd have a negative 5x and a positive 8x, so that'd be plus 3x minus 20. And then the second two would give you x squared plus 10x plus 25. So, hey, that is easy compared to what you're about to do. You FOIL binomial times binomial using FOIL. Binomial times binomial using FOIL. There's not a word for this. Can you think of a word for this? Because all FOIL is doing is making sure you take this term times both of these, and then this term times both of these. So now you have to have a word that says, hey, take the first term times all three, and the second term times all three, and the third term times all three. That word's called, that's a lot. That's what that word's called. That's a lot. So, but we can do it. First term times all three would be 2x to the fourth plus 20x to the third plus 50x squared. There we go. We got three of them. Now let's go to the next one. Plus 3x to the third plus 30x squared plus 75x. Now we got the last one. I'm about to run out of room, guys. Holy cow. Scoot over, computer. Last ones. Take the negative 20. That'd be negative 20x squared minus 200x minus, what's 20 times 25? Minus 500. There we go. We should have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplications. Logan, if you're working at home, have fun with that. There's only one x to the fourth, so 2x to the fourth. There's only one constant. I know it's going to be a minus 500 on the end. Now let's look at the cubic terms. There's two of them, right? So that's 23 x to the thirds. Let's look at quadratic terms. 3 of those, right? So we have 50. 30 is 80 minus 20, 60 x squared. Now let's look at linear terms. 2 of them, right? Looks like it. We have a 75 and a negative 2, so that'd be a negative 125x. If it helps you, you can cross them out as you combine them. So I took care of the 2x to the 4th. I took care of the 500. I did my 2 cubics. I did my 3x squareds. And my 2 linear. Yeah, I got all of them. Did anybody get it? Hey! Good job. Good job. It was a big one. Took a lot of just multiplying. What you might notice, the big key I want you to notice here is there were 4 factors. 4 factors means 4 roots, 4 zeros. When you have 4 factors, you get a polynomial to the fourth power. Those degrees always match up that way. All right, let's hit the rest of this. We have 16, 18. It says write each function in factor form. So if you went y equals x to the fourth minus x to the third minus 6x squared. What you're going to do on this one, you're going to take a GCF out to start. Yes, you can take an x squared out, and that would leave you x squared minus x minus 6. And I wonder, will it factor as x minus 3 plus 2? That gives you negative 6 and a negative 1x. With that, okay, there's 18. Now we'll go to 20. 20 says find the zeros of each function. So the function is y equals x plus 1, x minus 1, x minus 3. This is the easy kind. It's already factored. The zeros are negative 1, 1, and 3. Negative 1, 1, and 3. (22). It's already in factored form also. So what's your zeros? 0, 2, negative 5. Boy, after doing some of those other problems, 20 and 22 are like, well, that's a breath of fresh air. Nice, simple, and easy. If it gives you the factors, you have your zeros. And the last one. Find the relative maximum, relative minimum, and zeros of each function. So the function here, f of x equals x to the third minus x squared minus 9x plus 9. We don't have any current method to factor a cubic polynomial. There are ways that we'll be learning how to factor cubic polynomials, how to check factors. So with that being the case, turn on your calculator. Let's just get the answers from my calculator. Is that how you got them? So first thing I want to do, I could look at my graph and find the zeros, the places they intersect. If it's nice and neat, I could polysolve. Right? The polysolve will give me the zeros also. So first thing I want to do is just, I want to polysolve this. Let's see if I can do that. Menu, algebra, polysolve, find roots of a polynomial. What's the degree? Somebody, what's the degree? 3. Real roots. All right, so what's the, if you look here, it's asking for the coefficients. We got a 1, a negative 1, a negative 9, and a 9. And it tells me there are these zeros. Make it 3, 1, and 3. Did anybody look at them that way? Did you forget that you could do that? All right, so this is just going to confirm that I should be able to see the intercepts, or the zeros on the graph. So now let's go to the graph. Menu, escape, I need a graph. And I'm going to go menu, graph entry of a function. and I'm going to type that in, that function right there. So x to the third minus x squared minus x squared minus 9x plus 9. So now on the graph, I can see the intercepts, the zeros of -3, 1, and 3. The same thing I just got, right? But I also need what? Minimum, maximum. Well, if I look, this line is going up. This is a cubic line, so it starts down, zigzags, ends up. We've talked about that. I can't see the top of that, so I'm going to go menu. Anybody else need to zoom out? Zoom out. I'm going to put my center about right there. So I got to go a little bit farther. Okay. Now I've got a area where I can see the max, relative max, and relative min. Y'all see that? So what do we do in our calculator? Menu, analyze. Let's go with our max first. All right, this is lower bound. I'm going to go right. Now there's fine. Come across. Boom. We found him. We found a max. Guess that's it right there, isn't it? Negative 1.43, 16.9. Is that what y'all got? All right, so we got that. What we really need is, so the relative max is 16.9. That's the y value at that point. Okay? Let's do that for the minimum. Let's go menu, 6, minimum. All right, where's the lower bound? Right there. Come across, boom, we got a minimum. And it shows it nice and neat right there. Our minimum is a negative 5.05. We see right there, that's the y value. So it maxes out at 16.9 on that little curve and minimizes out at negative 5.05. And this is relative. Now, obviously, this isn't the whole graph. This is just in the cubic portion of the graph where it makes that little disco man. But you can have those things. You might have an ACT test question to ask about relative maxes and mins. If you have this calculator and you know how to put the function onto the calculator, you can see those things nice and neat. All right, so there are your answers to that homework. I'm going to stop the record. Have a good day.